The next section on the Chapter 8 Practice Test A practice test is Objective 6, predicting the products of a decomposition. It's just the opposite of the combinations, and we'll use our helpful hints page as well on this one. In fact, we're going to go down and write HH. We're going to identify which helpful hint we're using each time. To write these complete balanced equations, we'll have to start off by getting the correct formula. Phosphoric acid. You may need to go to your formula flow chart. Formula to name, name to formula. How do you name it? Do you see the word acid in the name? Yes. H plus is the positive ion. We're going to use the acid rules to find out which is the negative ion. So if I flip it over, the phosphoric acid comes from the phosphorate, but there isn't such a thing, but the phosphate ion, PO4 minus 3. H plus, PO4 minus 3, crisscross will be H3, PO4. When we heat this, it decomposes. Means I'm going to check my helpful hints for decomposition. So I've got a acid of some sort, and the very first rule in here says some oxyacids when heated. So we do have an acid. Does it have oxygen in it? Yes. This is helpful hint number 1. So what does it say to do? Some oxyacids when heated decompose to form water and the nonmetal oxide. So one of the things I'm going to need is water. Now right away that takes away 2 of my hydrogens. I'm subtracting out the water according to our helpful hints. So that takes 2 of my hydrogens. I've subtracted out the water. Definitely water is one of the products. The next product then, the next thing that it says to do is to balance the hydrogens. I've got 2 hydrogens on this side, 3 hydrogens on this side. So I'm probably going to need 6 on each side. So if I put a 3 there and a 2 there, at least the hydrogens will be balanced. Then I just need to count up what's left, and that's going to make my nonmetal oxide. There's 2 phosphorus on this side and 8 oxygens. However, we used 3 of the oxygens in the water, so P2O5 will be my correct formula. Is that now balanced? It should be, and if we check, we'll find it is. The next one, solid magnesium hydroxide, when heated, decomposes. Magnesium is a +2, hydroxide is a -1. The crisscross will be magnesium hydroxide taken twice. When we heat it, it decomposes. Let's check the rules. This is a metal and this is a hydroxide. One of my rules says some metallic hydroxides. That's rule number 2, helpful hint number 2. Some metallic hydroxides, when heated, decompose to form the metal oxide and water. Well, the metal in this case is magnesium, +2. The oxide of magnesium would be MgO. It's got to be MgO because magnesium's +2 and oxygen's -2. What's also left is water, H2O. And now we would balance this out. And if we check, we're going to find 1 magnesium, 1 magnesium. 2 oxygens, 2 oxygens, 2 hydrogens. That one is balanced. Moving on to the next one. The white powder, sodium chlorate. Sodium is Na with a +1 charge. Chlorate, according to the back of my periodic table, is ClO3 with a -1 charge. That's a match made in heaven, so it's NaClO3. When heated, decomposes. Let me check my rules. Is there anything about chlorates? Some metallic chlorates when heated. So this is a helpful hint number 4. When heated, decompose to form the metal chloride. The metal in question here was sodium. Sodium has a +1 charge. Chloride is a -1 charge, so it will form sodium chloride plus oxygen gas. When I'm looking at this, this doesn't look balanced yet. So how do I balance it? Well, since I can make a T-chart. Probably don't need one for this. If we've got 2 oxygens here and 3 oxygens over here, it seems clear that we're going to need them to be 6 on each side. So if I put a 3 there and a 2 there, that'll balance my oxygens. Now I have 2 sodiums and 2 chlorines, so I just need to double this, resulting in a balanced equation. Number 4, solid lithium carbonate is placed into a test tube and heated to cause decomposition. Lithium is a +1. Carbonate, according to the back of the chart, is a -2. When I crisscross that, the formula will be Li2CO3. It's decomposition, so that's the only reactant. We're heating it to cause decomposition. Let me check my rules or my helpful hints. I'm looking for something about possibly some carbonates. Here's one. Some metallic carbonates decompose to form metal oxide and carbon dioxide. This is helpful hint number 3. So the products are going to be metal oxide. Lithium is the metal. Lithium has a +1 charge. Oxygen has a -2 charge. So when I crisscross, it'll Li2O. The other product is carbon dioxide. Carbon dioxide. Count it up. I see 2 lithium matching 2 lithium, a carbon matching a carbon, and 3 oxygen, and 1 + 2 is 3 oxygen. That is a balanced equation. Solid mercury 2 oxide is treated with electricity to cause decomposition. Mercury 2 oxide. Mercury is Hg +2. Oxygen is -2. So the formula for that is HgO, and it decomposes. Need to find a helpful hint. This helpful hint has to do with binary compounds. It's just one element tied to one element. That's a binary compound. They break down into their elements. The elements that are in question then are mercury plus oxygen. Remember though that oxygen is never found all by itself. Oxygen is diatomic, so it'll be O2. Look to balance it. If I have 2 oxygens over there, I'm going to need 2 oxygens over there. And now that I have 2 mercuries, I'm going to need 2 mercuries. Next thing I probably want to do is go back up and reread my directions. Write a complete balanced equation for the following decomposition reaction, predicting the correct products. So trying to come back through and add the symbols that I need to. Phosphoric acid is aqueous. Water is a liquid, and if it's in water, then we are going to have an aqueous solution of that. Solid magnesium hydroxide, when heated, decomposes into magnesium oxide, which will be a solid, and water, which is a liquid. The white powder, we have a solid. When heated, decomposes into sodium chloride, that's a solid, and oxygen, which is a gas. Solid lithium carbonate is placed into a test tube and heated to cause decomposition. I'm going to end up with carbon dioxide gas, and lithium oxide is a solid. Solid mercury 2 oxide is treated with electricity. Gotta just double check. I said heat, and apparently it wasn't heat. I should have written electricity. It's not a reactant, it's not a product. It goes on top of or below the yield sign. Mercury is a liquid at room temperature, and oxygen is a gas.